Greeting learners. So we're going to continue with our session. We were doing question 8. So there is a question on this particular question 8.4. So I'm going to explain to make sure that I've responded to a question they did ask. Right, for the line g of x is equal to ax plus b is the tangent to the function at the point of inflection of f. The question was determine the equation of g being the tangent to this function at the point of inflection. So let's go to the solution. G of x is a tangent. Remember when we sketched the graph of this cubic function, it was having a point of inflection. A point of inflection is a place where, I'm just gonna give an idea here, is a point where the function is changing the concavity. Here, on the left of the point of inflection, the curve is concave up, and after the point of inflection, the function is concave down. So our tangent is going to be precisely here. Here would be our tangent. And here is the point of inflection. It's where the concavity is changing. So to determine the equation of this tangent, we're going to start by getting the first derivative. F prime of x is going to be negative 3x squared plus 12x minus 9. And then after getting the first derivative, we can also go to the second derivative, because that way the point of inflection where we're going to have the tangents passing through. F second of x will be equal to negative 6x plus 12. So we're going to equate this second derivative to 0, and this will allow us to get the point of tangents. So negative 6 plus 12 is equal to 0. We'll get negative 6 is equal to negative 12, and our x will be 2. So I'm also going to remind you that the equation of a tangent being a line, it will be of this form: y minus y1 is equal to mx minus x1. So this point here of tangency will be x1 and y1. M will be the gradient of our line. So we're going to replace this value of x in the original function, and then we'll get the second coordinate. X1 is 2. We need to get y1, and I'm going to replace the value of x in the original function. Then we'll be having f of 2 here. This will be the value of the second coordinate of a point of tangency. Here we'll be having negative 8 plus 24 minus 18 plus 4. And then I'm getting 2, meaning f of 2 is equal to 2. This will be the second coordinate of our point of inflection. Now, let's get the gradient of our tangent. The gradient will be given by m is equal to f prime of 2. And then we will replace here to get the gradient. Let's do a calculation. Is f prime of 2 in the first derivative? 4 times negative 3, we're going to give negative 12 plus 24 minus 9. Then we're getting 3. Our gradient is going to be 3. So if I'm going to come back here to get the equation of this tangent, g of x is equal to ax plus b, I'll substitute here x1 and y1 by 2. Here are the two values. X1 is 2 and y1 is 2. So we'll be having y minus 2 will be equal, our gradient is here 3, x minus 2, and then y minus 2 will be equal to 3x minus 6, y will be equal to 3x minus 6 plus 2, we're getting negative 4. And this is the equation of the tangent, g of x. Determine the equation of g. Here we are having the equation of g of x. That will be was question 84. So we're going to clean the board and go to question 85. That will be practically the last question for this question 8. Okay, here's question 85. Calculate the value of theta, the acute angle formed between the tangent. Remember, gx was the tangent and the x-axis in the first quadrant. So our tangent was g of x in the first quadrant. We need to get the value of the angle theta. So for giving an idea, just going to put a small sketch here for you guys to have an idea. Here's going to be x and here's y. Our curve was something like this. So if our tangent is here, they are talking about this angle here. So this angle will be our theta. To get that angle, we're going to the solution. We will write that m being the gradient. Remember, m is going to be equal to tangent theta. And from this formula, we'll get the value of theta. This will imply that theta will be equal to tangent negative 1 of m. Theta will be equal to tangent. This is actually arctangent of 3. We're just going to use the calculator, and the calculator will give us the value of theta. Tangent minus 1 of 3. Then the value here with 2 decimal places is 71,565. So we'll be rounding this at 2 decimal places, going to be 71,57 degrees. They gave us a precision saying it was an acute angle. The value of theta is 71,57 degrees. So we are done with question 8. I'm going to clean the board and we will go to the next question, and that is going to be question 9. So clean the board to go to question 9. All right, so here's question 9 now. We're done with question 8. Question 9, the diagram below represents a printed poster, as you can see down here. Rectangle ABCD is the part on which the text is printed here inside this. This shaded area ABCD is 432 square centimeter. This one here, ABCD, and AD is equal to X. AD is equal to X. ABCD is 4 centimeter from the left and right edges of the page. So here you can see it's 4 centimeter on the left and on the right, and 3 centimeter from the top and bottom of the page. From the top here is 3 centimeter and down here is 2 centimeter. So now the question is the main one. so that the total area of the page is given by a of x is equal to 3,456 over x plus 6x plus 408. So to show that the total area of the page, total area of this page is a of x is equal to this expression, we're going to start by saying that they say that AD is given as x centimeter here. And if we consider the shaded area ABCD is a 432 square centimeter, this one ABCD. Alpha, I'm going to remind you that if we are having a rectangle, to get the area of the rectangle is a length times breadth. So our length here is a x. To get DC, what are we going to do? We're going to say that DC, let me write it down so we're having a space here. The area will be ADX times DC, and this area is already given. So we'll be having that DC is going to be equal to 432 over x, because if we multiply length and breadth, we'll be getting 432. Reason why we're having x times 432 times x over x, we'll be getting 432. That is for the smaller rectangle ABCD inside. So we want to get, the question was then show that the total area of the page is given by this expression. So if I consider on the length here of the greater rectangle, I'm going to call this, let's call this L, and the breadth will be small l. So from here to here, this is going to be L, and if we consider the breadth is going to be a small letter L. So the surface area, this total one, will be L times the small l. Then we get the total area of the page given. So what are we going to say? We're having AD x here. If this is x, we will be adding 4 centimeter on the left and 4 centimeter on the right. So L will be equal to x plus 8. This is the length of the whole page. And if we want to get the breadth, it will be BC plus 3 plus 3. So it's going to be L will be equal to 432 over x plus 6. 3 plus 3. Then we get plus 6 here. And to calculate the total area, we will take the length times the breadth. So I'm going to write here down here, A of x will be equal to 432 over x plus 6 multiplied by x plus 8. And this product will give us the total area of the page. This is going to be the expression given down here. So let's do the multiplication. A of x will be equal 432 over x and x, we're getting 432. This multiplied by 8 here, what are we going to have? 432 multiplied by 8. We're getting 34.56. 34.56 over x plus 6x here. So we're going to have the last one will be 6 times 8. Then we get 48. As you can see here, I need some space here. I'm going to write it here practically because I'm just going to write it here because we don't have space here. We want to show this expression. I'm going to write it here. So our a of x will be equal to 432 plus 48. Then we're getting 408. So here's our expression, 3456 over x plus 6x. And here it will be 432 plus 48. Then we're getting 408. So we have shown that the total area of the page is given by this expression. You can see it here. So this is practically the end of this question 9.1. I'm going to clean the board, then we will go to the next question, and that is going to be 9.2. All right, this is the next question, the next sub-question, under question 9. 9.2. After getting the total area of the given page previously, a of x is equal to 3456 over x plus 6x plus 480. Then the following question 9.2 is determine the value of x such that the total area of the page is a minimum. So solution for this question. Determine the value of x such that the total area of the page is going to be a minimum. We need to get the first derivative of this area. And then we will equate this to 0. That will allow us to get the value of x. So the derivative of this, I'm going to remind you, when we are having a constant over x, the derivative of this will be k x prime over x squared. If you remember here, dealing with the derivative of a power, this can be x to the power of -2, like this. That's why if we're having a constant, it's going to be k x prime over x squared. And then here, remember, we're having a negative, so the negative will appear here. If we're having negative k, it's going to be negative k. So the derivative of 3,456 over x will give us negative 3,456 over x squared. And derivative of 6x, I'll start with this one so that we're not going to have a negative value. It's going to be 6 negative 3,456 over x squared. The derivative of the constant is 0. The derivative of 408 is going to be 0. So this is the first derivative of this expression. Now we're going to equate this to 0, and this will allow us to get the value of x. So 6, I'm going to get a common denominator, so we'll be having 6x squared minus 3,456. This over x squared, and this will be equal to 0. If I cross multiply, x squared times 0 will be having 0. So we'll be having 6x squared minus 3,456 is equal to 0. This will give us 6x squared is equal to 3,456, and x squared will be equal to, we're going to divide 3,456 divided by 6. X squared will be equal 3,456 divided by 6. Then we're getting 576. So x squared will be 576. The value of x is definitely going to be a positive value. We'll take the square root of 576. That will give us 24. So the value of x is going to be 24 centimeters. Let's write it like this. So here we are considering that x will be the square root of 456. If you want to write it, you can write x. Let me write it here. So it's going to be x is equal to square root of 566, and x is equal to 24 centimeters. We are done with question 9. So for today, we're going to stop at this question 9, and we will continue at the next session. Thanks for watching. Don't forget to subscribe, like, comment, and share the video. Definitely, we're having friends who will also gonna have the opportunity to follow, watch this. You can share. Thank you and see you.